Good morning, my dear friends. So now we'll go to the another problem on elastic shorting. I will read the this thing now. Problem now. A rectangular concrete beam 300 mm deep and 200 mm wide is pre-stressed by means of 15 5 mm 5 wires. Okay, wires located at 65 mm from the bottom of the beam and three bars of 50 mm, 5 mm wires located 25 mm from the top of the beam. If the wires are initially tensioned to a stress of 840 Newton per mm square, calculate the percentage loss of pre-stress in steel immediately after the transfer, allowing for the loss of stress due to elastic deformation of concrete. Take, okay, ES is equal to 20 kilonewton per mm square and EC is equal to 31.5 Newton, kilonewton per mm square. But these are the data he has given. Now we will try to see how it can be now, how the loss can be now calculated. See now, first try to understand the problem now. But in the problem he has given that the cross sectional area is 200 mm by 300 mm. Okay, so now you can easily mark your CGC can be marked here. It is 150 in the sense YT is 150, YB is 150. So but now the problem says that, okay, he has kept 15 wires of 5 mm 5 at a distance of 65 mm from the bottom. Okay, these are the wires, 15 bars, okay, 15 wires of 5 mm 5 at 65 mm from the bottom. Similarly, he say that he has kept another 3 wires of 5 mm 5 which are laid at 25 mm from the top. 25 mm from the top, he says. Okay, so now this is what he has given. So now our CGC can be now easily located. But now, since the wires are kept, some wires are at the bottom and some wires are at the top here now. Now I want to find out where the CGS lies. Okay, so now CGS can be found out by taking the moments of all these wires about the bottom or on the top. So now I will start taking the moments of all these wires about the soffit of the beam or at the bottom of the beam. Okay, so y bar is equal to, see now, 15 wires are there into the lever arm from the CGS to bottom. Here is 65, so 15 into 65 plus, I will come to the top now, 3 bars are there now, 3 wires into the distance from here to here up to the bottom. I think you can easily calculate, and its distance is now 275. Okay, so divided by 15 plus 3. 15 is the area of this, and this 3 plus 3. Okay, so it will give me 100 mm from the soffit of the beam. So CGS lies at a distance of 100 mm from the soffit. So now I have marked here your CGS. CGS lies at a distance of 100 mm from the bottom. So now CGC lies at a distance of 150 mm. Your CGS lies at a distance of 100 mm. So now you can easily calculate the eccentricity now. Eccentricity is the distance between CGC and CGS. So 150 minus 100 will give me the eccentricity. Am I right now? Eccentricity is now 150 minus 100. So it will give me 50 mm. So now I can easily calculate my AC now. Area of concrete, it is 300 mm by 200 mm. 300 mm by 200 mm will give me AC, area of concrete. Moment of inertia also can be calculated. It is BD cube by 12. Okay, it is so much. And but now since he has given me the value of ES and EC, I can easily calculate the modular ratio also now, M. Okay, so it is 6.66. Okay, now we shall try to calculate the total area of steel now. Total area of steel. So 15 wires of 5 mm 5. So 15 into area of one wire plus 3 into, okay, top there are 3 wires of again 5 mm. Okay, 3 into pi d square by 4. Okay, so area of steel is now 353.5. See now. Now, pre-stressing force he has given as, excuse me, he has given that the initial pre-stress is 840. Okay, so 840 is your Fs. Okay, stress in steel into area of steel, As. Fs into As will give me the pre-stressing force, initial pre-stressing force. Fs into As, stress into area of steel. Okay, it will give me the pre-stressing force. Okay, so pre-stressing force is now 296940 newtons. Okay, so now, but now I would like to first calculate the stress in concrete at the CG of the top of the wires. See now, now here wires are there, now 3 wires are now there. So now I want to calculate the stress in concrete FC at this level, at the top level, in sense where the steel is laid. So now Y becomes how much now? Y becomes 125. Y becomes 125 now. Am I right now? So now it is P by AC, Py by I. Am I right now? So it is now P value I know, area of concrete I know, again P I know, eccentricity E is, you have already calculated the eccentricity is minus 50 mm, you already calculated. Okay, now Y becomes 125, Y is plus, it becomes plus because it is above CGC, above CGC this distance Y is 125. Am I right now? 125. So it is now, so divided by I is so much, so it will give me plus 0.82 Newton per mm square. This is your FC value. Okay. Similarly, we'll try to calculate the stress in concrete at the CG of bottom wires now. In the sense, bottom wires are now here now. So Y becomes from here to here. Am I right now? Y becomes from here to here. Here the value is now 85 mm. 85 mm is the Y value from here to here. Am I right now? 85. So now, again now it is P by AC plus Py by I. So now P value I know, AC value I know, again P value, E value remains same, it's minus 50, Y is now minus 85 because it is below CGC. Okay, I value I know. So it will become plus 7.75 Newton per mm square. Okay, so now I think I can easily calculate the loss of pre-stress in top wires. Okay, due to elastic shortening. It is given by M times FC. M I know. FC is, it is top wires FC we have calculated. Okay, it is how much now? Excuse me. Top wires is now 0.82. Okay, sir. Now FC value is now 0.82. So now 0.82 we have kept. So loss is so much. Therefore, the percentage loss of pre-stress also I can easily calculate. This is the loss when I apply a pre-stress of 840 Newton per mm square. So this is the loss. Similarly, you can calculate the loss in the bottom fibers, in the bottom steel now. Am I right now? Same equation, M times FC, whereas now FC is now 7.75. Am I right now? It is 7.75. See now, I will show you. So now the loss is M times FC. So FC value is now 7.75. M remains same. So it will be so much. Loss is so much. So now if all I want to now calculate the percentage loss of pre-stress, this is the loss which has taken place, and this takes place when I apply a pre-stress of 840 into 100. So it will give me 6.4. So you can, this is the loss in the bottom fibers. So now total percentage loss is, if you add this and plus your top wires, it will give me 6.79. Okay, this is how you can calculate the loss. Okay, thank you very much.